Okay, so to explain the two first very quickly, first question asked me the correct interpretation of the part of the electron configuration shown here. So 2p4. I know that electron configurations are made of three things. They are made of the energy level, which is also the same as saying my period number in the periodic table, like my n. And they are made up of my sublevel, so that's 1. 2 is sublevel. And my sublevels include S, P, D, and F. And last but not least, they are made up of the number of electrons, and that number is this little number. So my first number for an electron configuration is going to be the period number or the energy level n. So if I look at A, it says that on the P energy level, well, that doesn't make sense because P is a sublevel. It's not an energy level. An energy level can only be a number. So that doesn't make sense because it said that it's a letter P. And for the same reason, I am getting rid of B. So it's not A and it's not B because energy levels can only be numbers, row numbers. C. On the second energy level, okay, I like how it said second, it's the number 2. There are 2 electrons. I see 4 electrons here in the 4th sublevel. I'm not sure what a 4th sublevel is. I know that there are only S, P, D, and F. So it should say a letter when it's talking about sublevel. And it says 2 electrons, and I have 4 here. So I'm gonna count C as wrong. That means that my answer should be D. On the second energy level, check, number 2, there are 4 electrons. All right, check, there are 4. In the P sublevel, check, that's my P sublevel. So my answer for this one is D. Number 2. So Jose conducted an experiment to determine the average atomic mass of lithium. What is the percent abundance? Ooh, so they're asking for a percent of lithium-7. And they're asking me about my lithium-7. Round your answer to the 100th place, and that means 2 decimals. You got it. So they're asking me to find a percentage. Here they have the name of the isotope. I'm specifically looking for lithium-7. And then they have the number of atoms in the sample. I know that a percentage is something over 100. So out of a total of 100, it is part of that. So here they made it easy for me because if I have this many number of atoms total, so 91 plus 9, which equals 100, they're asking me what is the percent abundance of this one? What is the percentage of my lithium-7? If I have 100 total atoms and they only want to know what's the percentage of lithium-7, which is 9, I have to take 9 and divide it by 100. That is my percentage. 9 divided by 100 is the same thing as saying 9%, 9 out of 100. When I want to convert that, so that's an acceptable answer, 9%. If I wanted to convert that into a decimal place, I would move the decimal 2 places to the left. To the left, to the left. And my answer as a decimal would be 0.09. So super simple, you're just finding a percentage here. Number 3. Jose conducted an experiment to determine the average atomic mass of lithium. What is the atomic mass of lithium based on this sample? So when we're finding this, remember we first have to turn our percentages into decimals. But here we don't have percentages, we just have straight up numbers. But remember up at the top, we were able to find the percentage by adding the total number and then finding what each part represented as a percentage. So I know that 91 plus 9 is 100. So my lithium-6, 91 divided by 100 to find the percentage of this total thing in lithium-6 is equal to 91%. So I'm going to keep it up there, 91%. And I know from above that the percentage of lithium-7 is 9%. Okay, so now that I have percentages, I can move my decimal 2 places to the left. To the left, to the left. and then I have 0.91. And I can do the same with my bottom one. To the left, and I have 0.09. The next part is multiplying the mass number times the decimal. So I have 0.91 times 6, and I have 0.09 times 7. So let me get my handy dandy calculadora, and I am going to have 0.91 times 6 is equal to 5.46, and 0.09 times 7 is equal to 0.63. Now last step is I need to add these two numbers. So 5.46 plus 0.63 is equal to 6.09 AMU. Never forget your units. That was the answer for the atomic mass of lithium according to these numbers, 6.09. Alright, and last but not least, this one. So it asked me to find the atomic number and the mass number of this stuff. So, okay, I know that a positive particle is referring to a proton, and I know that a neutral particle is referring to a neutron. I can right off the bat get mass number correct because I know that mass number is equal to protons plus neutrons. So I have to add the blacks and the whites. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I know my mass number is 21. That's the addition of all of these. Now my atomic number, I'm like, well, how the heck do I get this? Super simple. I know that my proton identifies an atom. Identifies an atom. So if I count all of my protons, I should find the atomic number. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 protons. So I'm going to go to the periodic table and find which one has an atomic number 9. And I see that fluorine has atomic number 9. So I know that this is fluorine, and the atomic mass of fluorine is 18.998. 18.998. So remember, my mass number will always be a whole number. My atomic mass will always be a decimal place, and I found it through looking at the periodic table.